All right, what's up, everybody? Welcome back. Time for data displays part 2. So let's jump right in. I'll try not to babble too much and get to it. So, intro to data displays part 2. So yesterday we started with some kind of basic data vocab, right? What's data, categorical versus quantitative data. And then we outlined some different types of graphical displays that we can use for each type of data, right? Ultimately, we created this table. So we saw that for a categorical data, like maybe your favorite sports team or what your major might be in college someday or whatever, your profession. We got a few options, right? So we got our pie chart. Those we're not going to stress about creating, but we want to be able to read them. Bar graphs, we'll make a couple of those. I have confidence you guys can do that. We will see some kind of bar graph analysis questions. I've seen some of those on the SATs, so we'll use some of that. And yesterday in our video, we started to create a frequency table for both categorical and for quantitative data. Right? Remember, a frequency table was unique and that it was the only display that's falling under both categories. So today in this video, we want to work through, we're going to start with the dot plot and then we're going to get into a stem and leaf plot. So that's our focus for now. Later on, worry about a box plot. And for our next in-person class, which for some of you is yesterday and for some of you is tomorrow, but we'll work on the histograms. I digress, nonetheless. So a dot plot. It's pretty straightforward. I think you guys are going to think it's easy. We're going to plot some dots. That's it. Let's do it. So here's a data set. This shows us the number of major hurricanes by year from 1997 to 2017. I did look this up. So on a quick side note, one reason I love statistics and I love teaching statistics is, right, you don't have to ask, when am I ever going to use this? No matter what field you might go into, there's a way that we can use data analysis, right? Whether you're looking at the effectiveness of some marketing campaign, or maybe you're an environmental scientist and looking at the impacts of climate change on weather, right? And some people think, or whatever, we're starting to see, right, we have more powerful storms this year. We have tons of named storms. So, right, we can use data to track that. Look, are we seeing more hurricanes? Are we seeing stronger hurricanes, right? And so there's a quick overlap of data analysis and, in this case, environmental science. So here we have a list of the numbers of hurricanes by year from 1997 to 2017, right? So there's just the number of major hurricanes. So create a dot plot. All we're going to do, we're going to create one axis, one horizontal axis. We always want to make sure we label this. And we want to label this, right, with what variable is being measured. And the variable measured in this case, right, is the number of major hurricanes. And then we want to number this axis. We want to look for our min and our max. So in this case, it looks like our lowest value is 0. Our highest value is 7. And so we want to number this axis from 0 all the way up to 7. And I'm doing this kind of sloppily and skipping through it because I also do know that I have my axis ready for me right here. Although I should fix this label and say number of major hurricanes, right? Because those are not the same thing. You might think, oh, what's the big deal? But if we looked at just the number of hurricanes, these would all be bigger numbers, right? We're focusing specifically on the major hurricanes. So as we create a dot plot, like I would challenge you right now to just pause the video and try to make a dot plot yourself. It's just going to be a bunch of dots. I bet whatever you think you should do is probably what I'm about to do. So pause the video and try to make the dot plot yourself in your notes. Hopefully you've unpaused it by now. So to make a dot plot, it's a very quick graph, but it gives us a nice idea of how our data looks, where data might be clustered, where there might be gaps. We're just literally going to go through, and let me just use my pen here. Let me make it a little thicker, and we're just going to put a dot for each data value. So I like 1. So there's going to be a dot at 1. And then 3. And then we got a 5, right? And another 3. Now, one thing that we want to pay attention to as I'm doing this, and I'm not doing a great job because my mouse skills aren't good enough, we want to make sure these dots are all the same size. I got that down. We want to make sure they're roughly evenly spaced. They're starting right at the same spot, like above the axis. Like for 6, I don't want the first dot to be here, and for 7, I don't want it to be way up there. Right? So we want to be consistent with our spacing, or we want to be neat and accurate because we don't want to distort the picture of what this data looks like. I think I was using that one. Nope, that was too big. So anyways, so back to it, right? You could finish this. You don't even need me. So we got a 4, we got a 2, we got another 3, we've got a 6, 7. I missed. That wasn't a good job, right, of spacing that evenly. We got 2 2s. Now, when I'm stacking these, right, I want the spacing to be similar, right? So these two both have 3 dots. They should be the same height. Again, otherwise we're going to distort how people perceive the numbers of hurricanes, right? I don't want it to make it look like 3 happen more often when there's the same number of dots for each. So we got a 5, a 2, another 5. As I do this, I'm like looking over to make sure my 3 dots are at about the same height. We've got a 4, another 2, a 0, 2 2s, lots of 2s, huh? A 4 and a 6. And that's it. Here we have a dot plot. And so a dot plot is a quick display, maybe a good tool when we did that choose your best player in case we come back to it. We could see, right, like the most common number of major hurricanes for a given year is 2, or we might say the mode is 2, right? We can quickly tell that just looking at this picture. We can see it wasn't very common for there to be 0 or 1 or 7 hurricanes, right? We could see that most of the time there's generally, I don't know, maybe from 2 to 5 major hurricanes in a given year. So a quick graph that gives us a nice, I don't know, I got nothing. I'm just gonna pretend that sentence never happened. All right, so dot plots, quick view of the data, easy to make. Dot plots work best with our discrete data. So dot plots work best when our data can only take on like specific, ideally whole number values, like minutes to eat breakfast, right? Like here, I can get a quick idea and I can see generally it looks like people either took 8 to 12 or 0 to 5 minutes, right? People either ate fast or took a little longer, not much in between. But back to this point, I don't really want to make a dot plot for something that can take on like any number. So like for instance, if I were going to look at GPAs, right, I theoretically could make a dot plot, but it's not going to be a very good picture because I'm going to have to do a lot of estimating. And there's going to be a lot of different numbers, right? So if I start to create a dot plot for GPAs, everyone's answer isn't going to be 0, 1, 2, 3, 4, right? Hopefully no one's going to say like 0. So here, like I'm going to have like, I don't know, like 2.1 and 2.2 and 2.27 and 3.1 and 3.4, right? And so in this case, right, a dot plot's not particularly helpful. We're probably just going to end up with a bunch of dots that we're estimating where they go next to each other. So if we have continuous data, we call it, and don't stress too much about that, but if we have data where it can take on any value, right? A GPA can be anything, any decimal between 0 and 4. A dot plot's not really going to be super effective. We'll probably lean towards a histogram in that case, which is coming up. So, but if we have something like how many pets do you have? 0, 1, 2, 3, 4. How many siblings do you have? How many credits do you have? Whatever. Where we're counting right incrementally and all the numbers are fairly close together, then a dot plot's going to be a good option for us. Or maybe how many points did you score in the last 9 games if we're trying to choose the best player. So that's it. We'll do some practice with these, both reading them, analyzing them, and creating them coming up. So the other graph for today we want to focus on is, I'm just checking my stopwatch here. I don't want to make the video, try to stay under that 20-minute mark, so I should shut up. So stem and leaf plot. So a stem and leaf plot, sometimes called a stem plot, if you're lazy like me and don't want to write all the words stem and leaf. So a stem plot is used for quantitative data, right? We know that because it was under the quantitative data heading in our table we created yesterday. When we start to create a stem and leaf plot, so we're gonna have some stems and some leaves over here. So you definitely want these purple things for stem plot in your notes. That's why I'm trying to do that to color code, right? Title, stem plot, and then here's what we need to know. So the leaves over here are only going to be the last digit. So leaves only the last digit, no matter what. The stems here, this is everything but the last digit. And we always, always, always want to provide a key. Like this stem plot right here does not have a key. If I didn't have the data set, so this is a stem plot showing the number of students enrolled in the dance class. If I didn't have this, I wouldn't really know how to read this. So we need a key that tells us, like 8/1 we could write is 81. So this is what I mean by provide a key. And the reason we need that is 8/1 or 9/4, whatever, 10/2, right? That doesn't have to be, right? So in this case, 10/2 would be 102. But it's also possible that 10/2 could be 10.2. We could create a stem plot that would show us that. And we'll see some examples of that on the next slide. The point for now is it's really, really important we have the key, because if I don't have the key, I don't know if I read these as 3-digit numbers or as decimals. So always, always make sure we provide a key. So I know I'm going quick. We're going to make a stem plot in a second. So I think seeing that construction will help us better understand these ideas here, that the leaves are the last digit and the stems are all but the last digit. This slide here, so these are just some different types of stem plots. As you know, as we try to read these, you just want to be aware that these things exist. Like, you don't need to be copying all these in your notes, but stem plots could have 3-digit numbers, right? So here they're telling us 14/5 is 145. I mean, we already saw that, right? Because if I jump back here, right, like 11, this, like this number right here, this represents that 111. That's in our data set. So we could have 3-digit numbers. Over here, we're seeing, and right, I just referenced, we could have decimals, right? So in this case, the key is telling us 24/1 is 24.1. It's super important I have this key, because otherwise I might have thought it was 241. Or over here, right? In this case, they're telling us 1/7, which is that's kind of a weird thing to use in the key, because that never occurs in this data set. So I'm kind of regretting that picture. But hey, whatever, it's good. We'll learn from it. But that would mean 1.7. So think to yourself, like, what number would this represent? What number would this represent? And hopefully you're saying stuff like 2.4 and 1.9 and so on. So like here, there's 2 numbers in the 2s, right? There's a 2.0 and then there's a 2.4. Not terrible GPAs, but we're gonna do even better than that. We could have back-to-back stem plots. So a back-to-back stem plot is a tool we use for comparing. So if we want to compare 2 different data sets, we can just use both sides of our stem. One side of the stem for one group, one side of the stem for the other, just to allow us to compare, right? Like here, we can see there are lots of males in these 30s, maybe, or it could be like 3.5s, right? But no females. And then lastly, over here on the right, we could even have a stem plot that shows percentages. So it's all about that key. The only way I know these are percentages, the only way I know 3/2 is 32% is because of this key. So we just want to be aware of the different types of variations we could see in stem plots. So last kind of new thing for today, let's make one. So here we've got a made-up data set, nothing fancy, not cool like my environmental science example earlier, but we've got some exam scores down here. And so we want to create a stem plot. Great idea to pause the video right now and try to make this stem plot on your own, right? That's how we can engage in this content a little more than just kind of like passively receiving the information. As we go to create this stem plot, we don't really need to label these as our stems and our leaves. I'm just doing that right now for the sake of learning and kind of connecting back to the notes we saw on our slides, right? 2 slides ago, saying the leaves are the last digit, the stems, everything else. Sorry for my mouse handwriting being so terrible. So as we think about our stems, we want to look at the lowest number 69 and the highest number is 99. So here, like, we don't have to start at 0 because we're not going to have anything until the 60s. So here I can start at 6, 7, 8, 9. And let's actually, just to add a 3-digit one, let's just pretend someone actually also got a score of 100, and then someone else came in and they also got a score of 100. So we have a repeat. So let's pretend that we're adding two data values. Two people got 100, so now I'm going to add a 10 to this. So these are all the 60s, the 70s, the 80s, the 90s, the 100s. So those are my stems, right? I'm just looking at the min and my new made up max to determine that. The leaves are going to be the last digit. So for like 69, we're going to have 69. And then 71 is going to look like this, 7/1 for 71. And then we've got 75. Just like with the dot plot, we want to try to keep these evenly spaced, try to keep everything about the same size, do more as I say than as I do because I'm so bad at writing with my mouse. Got to get my tablet. I'll stop complaining. 80 is going to look like this. Then we've got an 83. Then we've got an 84. Then we've got an 88, right? 80, 83, 84, 88. Then we'll go red. We've got a 92, a 95, a 97, and a 99. Looks like a 1-year-old wrote this. And then lastly, I'll go with some orange. We've got 2 100s. So the reason I wanted to add these, 2 reasons. One, I wanted to have a triple digit number to show that there's going to have to be a 10 in here. But the other reason is if a number repeats, we want to write that twice. If I just write 0 once, that makes me think there was only one person who got 100 in the data set. So if there's 2 people who got 100, I'm going to write the 0 twice. So we do want to show that repeat. And although mine is pathetically sloppy, there we see a quick sketch of a stem plot. But hopefully you're thinking something's missing. And that's our key. For our key, it doesn't like matter which one you pick. Like you could say 6/9 equals 69, right? I tend to always just pick the first one myself, but like whatever, you don't have to pick that. You can pick whatever one you want. You could say 8/4 represents 84. Like you just need to give me one combination so I know that 8/4 is 84 and not 8.4. Of course, we could use context clues and hope that an exam score is an 84 or not an 8.4. But, right, we need that key. So we want to make sure we provide our key. And if I really wanted to make this perfect, I'd also want some kind of a label, like exam scores, kind of a label / title. So if I were going to have you create a stem plot, there's like 4 things that I would be looking for. One would be the correct stems. One would be, right, so there's one thing. One would be having all the correct leaves, right? There's a lot that goes into that because I'm going to check all these. The third thing I'm looking for is do you have a key? And the fourth thing I'm looking for is do you have a label or title, whatever. Some kind of context that tells me what these numbers represent. And there's a quick version of our first stem plot. And then there's the answer key, but it doesn't have the hundreds I added, and I just made it on the screen, so I'm not really sure, right? We're probably good with this, right? Because like that one's just way neater than that one. Although I kind of ruined it with my black record. And that's it. That's dot plots and stem plots. So recap. Now, after this video, we got our frequency table down, we got our dot plot down, we got our stem plot down. So this is kind of helping you check, like, what do you need to be able to do? You should be able to make all the things with a check mark next to them. We haven't made a bar graph together, but you should be able to make one of those, and you should be able to read one of these. Is that seriously someone trying to write read? That's ridiculous, huh? Just pretend I wrote read. So make sure you know how to create all the graphs with check marks. Bar graphs just purple because I didn't do that with you, but I know you can do it. Histogram's coming up soon. And that's it, because histogram's coming up soon, not right now. So have a great day, everybody, and I'll see you in class.